Okay, again back to the previous topic. So yeah, so initially I was talking about last class. I gave you a grammar, then we had to find a language. Now another way is that maybe in some exams, language will be given, and you need to find the grammar from the language. Okay. So for example, this is just an example. The language is given, and the language is beaver and such that m is greater than equal to 0. That means there might be one a or there might be no a in the string, and n is greater than 0. That means there will be at least one b in any string. Your language is nothing but a collection of different strings generated with the help of the grammar. So, if the language is given in any string, there will be at least one B as per this rule. Okay. So, if you see what can be the possible strings from this language. Okay. One example is simple B. There might be just one B, which is acceptable by this language because there is at least one. Another possible string is AB. AB is also accepted. Why? Because there is at least one B and there is one B. Okay. A is greater than equal to 0. Then what can be the other possible strings? There might be BB, there can be AAB, there can be A, B, 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 and so on. Okay. So if you see, there are various possible strings that you can generate from language. So how can we generate the production? We need to find the production rules such a way that we can generate some of these strings or at least all the strings. Okay, first is B. For example, let's take we want to generate the string B. Remember, there will be always a starting symbol. Okay, so we will take a starting symbol. Okay. Here I'm taking a production, for example, B. Okay. For example, I'm taking here S equal to B. Then I'm again giving a production B equal to small. So from this production, I can go from S equal to B. Then I can replace B. So B is there. So these two are correct. From B, I can generate single B. Okay. But from this production, only two production, I cannot generate these terms AAB, AB, and AB. Anything including A, right? From this two production, I can generate only single string B. That is B. Okay. Now another possibilities are like A and A. That means we need another. So we need a production rule from where I can generate A, at least one A or no A, still fine. For example, if I take S equal to A and S, okay, from this production rule, what is the possible strings we can generate from S equal to A, S, okay, that means from S I can again go to B, right? I can go to capital B, then from B I can generate B. Okay, AB is there in the language. It's correct. So S is another possible production. Okay. Now we need another production from where we can also generate like A, B, B, something like this. Okay. So now if I take another production rule, B and B. Okay. From B, it will go to a small b, and again it will go to a capital. So from here, I can just use this one. That means you can generate BB. Right? From here, you can generate BB. Okay. Now, as a whole, you can see. Suppose I am starting from S equal to B equal to B. This is accepted. Then let's take another one, capital B. From B, now I am using this production. B and capital B. Okay. From here again, I can replace B with B. This is also accepted. B, B, these are accepted. Okay. Now let's take the other production as equal to A and S. Okay. From here, this S, I can use this production rule. Okay. That means A equal to capital B. Okay. From here, again, I can replace B with small b. That means the same thing, AB. So AB is also accepted by the language. Right? Now try other one, A and S. Let's just replace A with AS. Okay. I replace it A with AS. This S is I'm taking this one, AS. A. Whatever production you want. You can take, it's not like whatever production you can take, you have to at least match it with the language, whether it is satisfying the conditions or not. For here, remember there will be at least one B, and all B's will be after A only. Okay, now you cannot take a production rule like S equal to B and AS. Because from here, B will come first. If I use B, A from S, you can maybe again replace anything. B cannot come before A, right? B will always come after A. So you have to take care of these conditions. Then you can think about the production. Most of the times, you just see what are the possible states. Then you can generate any production. The more practice you will do, it will be easier for you. You just need to generalize the language and the what possible strings. Once you know the string, then you can generate anything. For example, you know there will be one B. So directly from here, you can take any symbol. Not necessarily it will be B, you can take from A to B also. Just remember, from non-terminal only, you can go for terminal symbol. From the variable only, you can replace the terminals. Okay. So you have to make provision such a way that all strings are accepted by this one. For this three, the simple one is included B, BB, AB. Now it's possible there might be many A before B. So you have to satisfy that condition as well. Right? So from here, I can just from S replace A, B. Right? From here, I can simply replace AAB. This is also accepted. Right? See, this is also accepted. And let's take another example. Like now, I want to take this one. A and B. Suppose from S, I have directly to B. From B, I want to use this production rule. That means A, B, and capital. Okay. From B here, I can again replace B with BB. This is also accepted. Right. So now you can see these productions are just enough to generate any strings which is acceptable by this particular language. Okay. So what will be your grammar? What will be your grammar? You can see your grammar is, it's a quadruple. There will be non-terminals. What are the non-terminals you have to use? S, capital A and capital B. Right? These are the variables you have taken or non-terminal. What are the terminal symbols you have taken? A and B. Right? And what is your starting symbol? It's just X. Now we just need to write the productions. So what are the productions you have taken? See, it's up to you what production rule you use, but just remember whether it is satisfying the condition or not. If it is satisfying the condition, it's fine. Okay. So 1 to 2 is AS. Another you took from S, you can go to B. Another production you took B goes to small b. And B also goes to small b capital. Okay. So these are the production rules we have used, and this is the grammar for the particular language. You can try it another one. Okay, I have done one. I'm just giving one a similar one. You can try to find the grammar. For example, language is given p power n. Just same I'm giving. Just the condition is different. Okay, same a power m and b power n. That means it's not important that number of a and number of b will be same, but b will be always after a only. We cannot come before a. Okay. Then I'm giving the conditions that m is greater than 0. Okay. And n greater than equal to 0. Okay. It's just simply same language, but the conditions are different. Initially I said m is greater than 0 and n greater than 0. That means there will be at least one b. Now here in this condition, there will be at least one a. At least one a will be there in the string. Any string you take, there will be at least one string. And there might be one b or might not be any. Okay, we try out. Equal to almost similar. Production will be this is a 4. Okay, this one you try. It's the same thing I just did now. Just you need to understand how your productions might vary depending on the conditions. These conditions are important. Okay, everyone try this one. This part clear? I know it's a bit confusing. It's from the language, it's easier to generate. I mean, if grammar is given, it's easier to generate the language. But the vice versa is a bit tricky. Right? Because all production rules are already given. You just need to follow some of the production rules and just see what can be the possible strings. Then whatever strings you generate, you just generalize. Then you just get the language, right? But when it's the other way around, this language is given, then you have to find out the production. Okay? Sometimes in exams, I'm mostly talking about the competitive exam. Sometimes they just give the grammar, then you have to find the language. Sometimes they give the language, and you have to find out the grammar. So I'm just giving you examples of all those type of questions. Okay, at least know the concept. If you know the concept, then it's fine. Okay. So this one you try. I'll say, remember I said there are different types of grammar. So what are the different types of grammar? First is type 0. Okay. Type 0, type 1, type 2, and type 3. And all of them have different names also. Okay, type 0 is your unrestricted grammar. Okay, type 1 is your context sensitive. I mentioned about this earlier also. Means now we are following sequence. Context sensitive. Type 2 is context free. Type 0 is the regular grammar. So all the grammar we are just discussing are the regular grammar. Okay. So there are 4 types of grammar. Type 0, 1, 2, 3. Or you can say regular grammar, context free, context sensitive, non-restricted. Now when we will go like chapter by chapter, we will go from down here. Okay. So regular grammar is this type 3 regular grammar is the subset of context. This is very important. Just remember all the time they ask. Regular grammar is the subset of your context free. Context free grammar. That means all regular grammar are context free grammar. Okay. Then again, context free grammar is the subset of context sensitive. Okay. That means all context free are context sensitive, but all context sensitive are not context free grammar. I guess you guys already know the concept of subset and all. Then comes the unrestricted grammar. Or another name is your recursively enumerable language. Okay. Now each of these grammar has particular structure. Means there are 4 types of grammar. How will you know which one is what type of grammar? Right? So each of these grammar has particular structure. Now always remember regular grammar accepted by your finite state automata. We will learn about it in the next class. Context free is by push down. Context sensitive by linear bounded. And this one is by Turing machine. So basically Turing machine can accept any language or any grammar. So RG is the subset of context free. Again, it is subset of context sensitive and it's the subset of recursively enumerable. Now we will start from the regular grammar. Okay. Our first next chapter is on the finite automata or finite state automata. So finite automata always accepts regular grammar. For type 3. Okay. So how will you know whether a grammar is type 3 or not? Okay. You guys already know any grammar means regular grammar we can represent in terms of 4 tuples, that is NT, P and S. Correct? Non-terminal, terminal, production rule and starting sentence. Now, type 3 grammars must have a single non-terminal on the left-hand side. Okay. What are the main points? Should have at least single non-terminals. Non-terminals on left side. These are the rules, okay? And your right side will consist of a single terminal, or there might be another non-single terminal. Okay, that means there will be a single terminal symbols or more non-terminal symbols on the right hand side. Okay. So you can generalize this term as, like, suppose this is the non-terminal symbol. Okay, single non-terminal on the left hand side. This is the left hand, and in the right hand side there will be a single terminal. Okay, or there may be more than means more non-terminal symbols. Okay, so this is the main structure of your type 3 or regular grammar. There will be single terminal symbol on the left hand side from where you can just replace any non-terminals. Okay. So right hand side में हमेशा non-terminal रहेगा, that means small letter words, and there might be a small letter word followed by the capital letter, that means non-terminal. Okay. You can just write this as single terminal followed by non-terminal. See, that's why this is a regular expression. Just now we generated the language. One non-terminal symbol or variable at the left-hand side. Then in the right-hand side, there can be one terminal symbol. Here it is just B, or there can be like one terminal symbol followed by one variable or non-terminal. So this is nothing but your regular grammar. This is the structure of a regular grammar. So if you see any grammar is in this form, that means it's a regular grammar. So here X and Y belongs to your non-terminals and A belongs to your terminals. Okay. And now there should be a production rule too, right? What can be the possible production rules for that? Here, from starting symbol, you can go to epsilon. It is possible. Okay, production rules most of the times it's already given. In case of regular grammar, this is accepted. Okay, but this is allowed if S does not appear on the right side of any rule. Okay, so this is allowed if starting symbol doesn't appear in the right hand side. Okay. So in your regular grammar, you will find this production only when S does not appear on the right hand side. For example, in some places you will see S. Okay, in these cases maybe this one is not allowed. Okay, so here this rule is allowed if S does not appear on the right hand side. So example, you can say X epsilon X equal to A, or you can go to A y, this is already included, and y equal to, this is the regular graph. This is allowed because x is not inside. You can also replace it with s, doesn't matter. The same thing you can write it like s belongs to a, s belongs to a, or a, b. Then from b you can go to. Okay, what symbol you use, what alphabets you use, doesn't matter. You can take x, y. Sometimes people also take like 0, 1 and all. Okay, but it's easier to understand when you just take alphabets like A, B, C. Same, it's just equivalent, same. You can use any symbol. For this production, maybe X is the starting symbol. Okay, then you can just write S is the X here. For this one, X is the starting symbol. Since it's easier to read that S is the starting symbol, we always use the alphabet S, but it's not convention. Means you can use X, Y, Z, any symbol as a starting symbol. Just that you have to mention that maybe X equal to S. This means starting symbol for the particular graph. Okay, so this is the rule for type 3. Okay, similarly, we have a structure for type 2 grammar. Type 2 grammar we will mainly learn when we will go to push down automaton. Okay, type 2 or context free. So here the formation of production must be A to Y. That means there will be A is the non-terminal, and this small y means A will be a non-terminal. And here this y, this is a small y, okay? Small y belongs to a union of terminal or non-terminal, okay? That means it can be any strings of terminals and non-terminals. There is no format. So what can be the possible example? Example can be S equal to XA. Let's take A, it will be easy. Then I can say A to small a. Then I can say production rules A to AA. Then I can say A equal to A, B, C, or A belongs to epsilon. Okay, all can be possible. See, what's the difference here? In case of regular grammar, the non-terminal will be always followed by a terminal, right? It will be always in this form. Non-terminal will be followed by a terminal. But here is nothing like that. It can come first or it can come last. Doesn't matter. You can write AA, you can write AA, anything. There is no sequence like after A, B should come, after B, A should come, like that. It is not given. Okay. So in the left hand side, there will be a non-terminal, and in the right hand side, it can be a string of terminals and non-terminal, and it can be in any sequence. Okay. But left hand side, there will be always a non-terminal sequence. Okay. Then type 1. Type 1 is the context sensitive. Here the production must be in the form alpha A by say alpha A beta, or you can also say like alpha Y and beta. So here A and non-terminal, A is your non-terminal, and this alpha, beta, you can write Y, everything can be a string of non-terminal and terminal. Okay, this symbol means it can be string of non-terminal and terminal. And alpha and beta might be empty. Okay. But this Y, A and beta, alpha and beta can be empty. Both can be empty. But this Y can never be empty. Okay. And the production rules belong to alpha. From starting symbol, you can generate an empty string is allowed if S doesn't appear on right hand side. Okay, it's similar to your regular grammar. So this is your type 2. What can be the possible example? Like A, B, A, B. If this is acceptable, then B, B, A, then B. Anything is possible. Okay. Don't worry about this type. We are mainly concerned about type 3. We are going to learn about context free and the regular grammar. Okay. Type 3 and type 2 are the main grammars we are going to learn. And lastly, the type 0, the Turing machine one. Okay. Nowadays, we are not so much concerned about the context sensitive one. Okay. Just you have to know the structure. For type 0, it should be always in the form equal to beta, where alpha is the string of both can be string of terminal and non-terminal with at least one non-terminal. One non-terminal, and alpha cannot be null. Okay, this left hand side can never be null, and beta can be a string of terminal and non-terminal. So example, you can say from S, A, B, B. Just know the example. When you learn about the Turing machine, we'll learn. This is just like review. What are the different types of grammar and what can be the possible structures. Okay. So type 0 will be in this form. That means left hand side can be a string of terminals and non-terminals, and there will be at least one non-terminal. Okay. And beta will be string of any terminal and non-terminal. I know this terms non-terminal, terminal is confusing sometimes. For type 1, it should be in this form. Your A is always a non-terminal or variable. Then whatever variable there, that will be a string of terminals and non-terminals. And alpha and beta can be empty. This string can be empty. Okay, but this Y will never be empty. Means, in other way, you can say this is means right hand side will never be empty. But from starting symbol, you can generate an empty string only when S does not enter the right hand side. Okay, this can be of any form. So we are mainly concerned about context free and the regular grammar. Okay, we will learn about it more in upcoming chapters. This is just preview. Remember type free, what is the structure? Okay, and remember context free, what is the structure? Okay, both are almost similar, just that in type 3 or regular grammar, non-terminal or variable will always follow. It will come after the terminal symbol. But in case of context free, it's not like that. It can be in any sequence. That's the only difference in normal. Okay. So you guys try this homework. Find the language and let me know the answer in next class. That is tomorrow. Okay. So tomorrow we will go to the different types of finite automata. Okay, these are just the basics. Okay. Any confusion in this part? This is just theoretical part. Okay, once you read it, you will understand. No, ma'am. No, ma'am. It's which part? Which part is no, ma'am? At the moment, just remember, no confusion. At this time, just remember what are the types of grammar. And you are mainly concerned about these two things only, type 2 and type 3. Okay. Later we will learn this type 0, but that portion is very small. শুনা পোৱা নাই তাৰমানে বাহিৰত ঘূৰি ফুৰিছে পাপা okay that's all for today. So these are like the basics. So when you will learn about final state automata, then grammar, there are more to. This is just like preview. To be clearer to you guys whenever you will keep doing the things. Okay. Stop sharing. Can you guys follow it? Am I going too fast, too slow? I'm trying to go as slow as possible because I know this subject is like confusing in many ways. When you study it, it sounds very easy, but when you are going to actually do the problems, it's always confusing. But again, if the concept is clear, then it's very easy to do all the problems. And always keep your pen and paper for this particular subject. Okay, you cannot learn it without having any paper and pen with you guys. Always keep your copy and pen for this particular subject. If you don't try it yourself, you won't understand. Okay. So if you are just doing it like casually without pen or copy, just doing something else and just in the class and doing something else, then you won't be able to learn it. Okay, that's all for today. I'll see you in next class tomorrow. Okay, thank you all.